and I'm presenting my screen. Can you see the screen equations?
Yes, sir.
Yes, sir.
So you had seen that the per unit speed del V. Sorry. Per unit speed B, that is equal to 1 minus IR, where I is the motor current in per unit and R is the armature circuit resistance in per unit. I is given by armature current divided by the rated armature current, and the per unit resistance is given by the actual resistance, that is capital R, divided by the nominal resistance, that is given by V upon IA nominal. And we could also write V is equal to 1 minus mu R if the flux is constant at its rated value. Now mu will be the per unit torque and R is the per unit resistance. V is the per unit speed. It is not the voltage, it is the speed. Correct?
Yes, sir.
Now suppose we have this motor. This is the armature circuit. This is the armature of the DC shunt motor. This is the field winding, and there are some external resistances in the field circuit, which for the time being we are not changing, so that the field current is constant at its rated value. There are three external resistances, RRH1, RRH2, and RRH3 in the armature circuit. Okay, this is the external resistance in the field circuit which we are keeping fixed. These are the external resistances in the armature circuit. And as you can see here, there are four contactors being used. Okay, one is the line contactor, that is L, and there are three contactors, 1A, 2A, and 3A. I hope all of you have studied contactors in your UG course. Is that correct? Have you or have you not? Sumit, did you study contactors in your UG course?
Yes, sir.
Suman?
Yes, sir.
Okay, so all of you know what are contactors. Nowadays, we can replace the contactors with SCRs also. Okay. But earlier, only contactors were there. Okay, so there are four contactors here. This is the line contactor. Whenever we want to start the motor, this contactor will be closed. And these three contactors, 1A, 2A, and 3A will be open. So that your armature current will flow from the supply through the line contactor L, armature circuit, and then through the external resistances RRH1, RRH2, and RRH3, and back to the supply. Okay. The purpose of these external resistances is to limit the starting current of the motor within permissible values. After some time, as the motor speed increases and the back EMF increases, the armature current decreases. Now, to maintain fast starting of the motor, okay, you want to keep the armature current at its maximum permissible value. So what you are going to do is, after some time when the armature current decreases, you will close one of the contactors. Let us say you close contactor 1A. As soon as you close contactor 1A, your external resistance RRH1 is bypassed. It is removed from the circuit. The current now flows through L, armature, 1A, and then RRH2, RRH3. As soon as you remove RRH1, the armature circuit resistance decreases, so that your armature current increases, the motor torque increases. The speed goes on increasing. Again, as the speed increases, the back EMF increases, so that the armature current decreases. Again, to maintain a high value of starting torque, after some time we close contactor 2A, and similarly after some time we close contactor 3A. When all the three contactors are closed, all external resistances are removed from the armature circuit. Only the armature resistance remains, so that your motor starts running on its natural characteristic. Is that clear, everyone?
Yes, sir.
Yes, sir.
Today, we are going to see how to find the values of RRH1, RRH2, and RRH3 from the motor speed torque characteristic. Okay, what is the purpose? Today's class, we have to see how to determine the values of RRH1, RRH2, and RRH3. There cannot be any general resistances, and we cannot say let us put an external resistance of 10 ohm or 20 ohm or 50 ohm or 100 ohm. No, we have to calculate the values, and accordingly the resistances have to be inserted in the armature circuit. Okay, clear? Yes or no?
Yes, sir.
Yes, sir. Yes.
Yes, sir.
These are the speed torque characteristics of the motor that we have been drawing till now. Now here you see a number of characteristics. How many characteristics do you see? You see 4 characteristics. This is the first characteristic, second characteristic, third characteristic, and fourth characteristic. This will be the natural characteristic, where only the armature resistance is present in the circuit. There is no external resistance. Whereas this characteristic, there will be some external resistance. If you further increase the resistance, you get this characteristic, and if you further increase the resistance, you get this characteristic. We have seen that the per unit speed V is equal to V0 minus I into R. So as you go on increasing the external resistance in the armature circuit, your speed drop is going to increase. Del V, that was equal to I into R, that will keep on increasing, so your characteristic will keep shifting downwards. The slope will go on increasing, the characteristic will keep shifting downwards. Okay, is this clear?
Yes, sir.
As far as the natural characteristic is concerned, this can be drawn by finding 2 points. The first point will be corresponding to the no load speed. So at the no load speed, V will be equal to V0, that is equal to 1. Correct? The no load speed, V will be equal to V0, that is equal to 1. V was equal to omega upon omega 0. At no load, omega will be equal to omega 0. So in per unit terms, your per unit speed, V will be equal to 1. The second point on this characteristic can be obtained corresponding to your rated torque. And this line corresponds to mu is equal to 1. That means rated torque. If we see the equation, V is equal to 1 minus mu R. And you remember the equation, V is equal to 1 minus mu R. So along this line, the value of mu is equal to 1. So this point will be simply, the speed will be simply V is equal to 1 minus R, where R is your armature circuit resistance in per unit. That will be simply equal to your armature resistance divided by the nominal resistance. There is no external resistance in the circuit here. Okay? Is this clear? This point corresponds to the no load speed. Okay? V is equal to V0, that is equal to 1. This point will be equal to, this point will correspond to the speed V is equal to 1 minus R. That means, what is this value AB? How much is this length AB? Anyone? How much is the length AB? This length.
Mu R.
How much is it?
Mu R.
One minus
One?
mu nominal.
1 minus
Mu
V
nominal.
nominal. V nominal or mu nominal?
V nominal, sir.
V nominal. No, it is not 1 minus V nominal. This is V nominal. This is the per unit speed at rated torque. This is V nominal. How much is this? So you are saying this is 1 minus V nominal. ठीक है,
V naught
1
minus
minus
V
V
nominal.
nominal. ठीक है, 1 minus V nominal is the correct answer. But there can be a better answer. What is the better answer? How much is the length AB?
V naught minus V nominal.
ठीक है. It is same. 1 minus V nominal or V naught minus V nominal is the same thing. There can be a better answer. What is the better answer?
Sir, V1.
Speak a little louder. Yes, anyone else? Sumit, how much is AB?
So drop in armature resistance at
No.
rated current.
No.
Drop in
But
relative
armature resistance change.
speed.
Current change. It is the drop in speed in per unit, but what is the length AB? How much is it? I want to draw AB.
So drop in speed 1 minus S into B rated.
Anyone else? How will I draw AB? I can draw AB from the answers that you are telling me. Can I draw AB from the answers that you are telling me? No. I want to draw AB. I want to find the length AB on a graph paper. How do I do it?
So mu into R.
Yes, mu into R. And what is the value of mu? What is the value of mu?
1
Here. 1. So this is simply equal to
R.
small r. Yes. And armature resistance in per unit. And this clear, all of you. Along this line, B is equal to 1 minus mu into R. Here, this is the natural characteristic. So R is simply the armature resistance divided by the rated resistance. Take a small r. So along this line, B is equal to V0, that is 1 minus mu into R. And along this line, mu is equal to 1. So this point corresponds to V is equal to 1 minus R. This is the line of one line. Okay? This distance AB is simply R, so that this point is equal to 1 minus R. Okay, is this clear? Yes or no?
Yes, sir.
How much is the length AB?
Yes,
It is
sir.
equal to small r, where r corresponds to the
Small r.
armature resistance only. Okay? Okay. I add some external resistance so that the characteristic shifts. We get this characteristic. Then how much is the length AC? I'm adding some external resistance. Let us say R1 or let us say R3. Okay? I'm adding some external resistance R3 so that your speed torque characteristic shifts downward. Now, what is the length AC?
R plus external resistance.
Yes, it is still equal to small r, but small r now includes the armature resistance plus the external resistance. Okay? AC is still small r, but small r now includes the armature resistance plus the external resistance. Or small r is now equal to R ARM plus R3 divided by R nominal. Okay, is this clear? Yes.
Sir. Yes, sir. Yes, sir.
What is the length BC? How much is BC?
AC minus AB.
So R2 minus R1.
Sir, mu into R external.
RA2 minus
Uh,
RA1.
R external.
Yes, it is R external. AC minus BC तो है ही, AC minus AB तो है ही, but BC is equal
yes,
to
sir. R external.
R3 divided by R nominal. ठीक है? Clear? Yes.
Yes, sir.
I add another resistance R2. Okay, so now there are three resistances in the armature circuit. Armature resistance itself plus R3 plus R2, so that the characteristic shifts further downward. Now, what is the length AD? What is the length AD?
Sir, R plus R1 plus R2.
It is still small r, but small r is now equal to R armature plus R3 plus R2 divided by R nominal.
R nominal.
How much is the length CD? It is R2 divided by R nominal. Okay? CD is R2 divided by R nominal. How much is BD? R2 plus R3 divided by R nominal. How much is AD? RARM plus R2 plus R3 divided by R nominal. Is this clear? Yes? Yes or no?
Yes, sir.
I add another resistance, R1. The characteristic shifts further downward. Now, how much is AE? It
R
is small
armature
r.
plus R1 plus R2 plus R3 by R nominal.
Yes. Now it is R armature plus R1 plus R2 plus R3, everything divided by R nominal. How much is DE? It is R1 divided by R nominal. CD, R2 divided by R nominal. BC, R3 divided by R nominal. AB, R armature divided by R nominal. Clear, everyone? Yes?
Yes.
Yes, sir.
It should be perfectly clear. Okay? This distance DE is R1 divided by R nominal. Is this distance also equal to R1 divided by R nominal? Yes?
No, sir.
No. What has changed? Has the resistance changed?
So
From
per
here to
unit
here.
torque has changed.
Yes, per unit torque has changed. Here the per unit torque was 1. Here the per unit torque is mu2. Okay? This will be has to be multiplied by mu2. Okay? This will be mu2 multiplied by R1 divided by R nominal. Okay. So initially, all three resistances are present in the circuit: RH1, RH2, and RH3. These three contactors are open, and we are closing the line contactor. From where will the motor start operating? From this point or from this point? From this point capital A or from this point capital B? From where will it start operating?
Cap A.
Sir, A, sir.
From here.
Yes, sir.
From here.
Yes, sir.
Yes. Yes. So when you start your bike, does it start at rated speed?
No. To start from
It starts at 0 speed. It has
Zero
to start from here. Okay?
yes, sir.
So here we have to select a range for the starting torque. What torque you need at the time of starting. So here you see two ranges. One is mu1 and the other is mu2. Or in terms of current, armature current, corresponding to I1 and I2. What will be the value of I1? How much current will you allow? Maximum current you will allow at the time of starting.
V upon my armature resistance.
V upon armature resistance. Okay. This is something like what came first, you know, the chicken or the egg. What will you decide first? The armature current or the armature resistance? क्या डिसाइड करेंगे पहले?
Armature resistance.
Armature current.
You decide the armature resistance or the armature current?
Armature resistance.
current.
You will first decide the armature current, and from that you will decide the armature resistance. Correct? Yes or no?
Yes, sir.
First you will decide the armature current, how
Yes,
much
sir.
current your motor can handle, and from that you will decide the resistance. Not the resistance, it can handle any value of resistance. Okay. The thing is how much current it can handle. Okay. First you will decide the upper limit or maximum permissible current that your motor can handle. Who is limiting this current? Why is I1 here? Why is I1 here? Why it is not here? Who is limiting this current?
So external resistance.
Back EMF or external resistance.
Nahi. That is not the question. Why this armature current, maximum current I have kept here? Why not here? Or in terms of absolute values, let us say I am saying that the maximum permissible current is 10 ampere. So why 10 ampere? Why not 25 ampere?
So depending upon the application, sir.
No, your application is saying it wants this much current. Rated current. This is the rated current. I is equal to 1. You have gone much beyond your application at the time of starting. So why 10 ampere? Why not 25 ampere? Who is limiting this current?
It's the back EMF.
No. That is not the answer I am looking for. What is the back EMF here?
0.
Who
Start.
is limiting this current?
So
Why only
armature
10
resistance.
ampere? Why only 10 ampere? No, you are thinking in the wrong direction. Why only 10 ampere? Why not 25 ampere?
So maximum permissible current in the armature.
Who decides that current? Maximum permissible current. Who decides that current?
Maximum in the starting the back EMF is 0 in the motor. So that is the maximum.
winding.
And means after this back EMF will come and it will reduce the current.
Sir,
Means
armature
Priya,
conductors.
maximum value of the
you
current
are
will come in the starting.
Priya,
When
you are
we are
thinking
running.
you are thinking in the wrong direction. That is not the question. Yes, then
Sir,
somebody else.
armature conductors, sir. Current carrying capacity of armature conductors.
Yes, that is one. Second,
Applied voltage.
no.
So armature winding.
वो तो आ गया ना. I just said that. Current carrying capacity of the armature conductors. That is one. What is second?
Maximum flux produced.
DC shunt motor.
That depend upon the load.
No. Load is asking for this much current, man. It is the commutator circuit. correct? How much current can be passed through the commutator without sparking? That is the main deciding factor in the upper limit of the armature current in case of DC motor. Okay? More important, even more important than your current carrying capacity of the armature conductors. That is decided by the insulation. Okay? So your commutator, how much current you can pass through your commutator without sparking, that is the thing that is deciding this current I1. Just a minute. ठीक है. Can you hear me?
Yes, sir.
ठीक है. In case of a DC motor, the armature current is limited by the back EMF, but at the time of starting, the back EMF is 0. So your motor current is very high. Even 5 to 6 times the rated current is possible. Okay, I think you must have studied all this before. Yes or no?
Yes, sir.
At the time of starting, the current can be 5 to 6 times the rated current. Okay. If you allow 5 to 6 times the rated current to flow through the motor, your motor armature circuit might get damaged. Okay. So you cannot allow 5 to 6 times the rated current to flow through the motor even at the time of starting, even for a very small duration. So you have to limit the current. So to what value that has to be limited? That is decided normally by the armature conductor's current carrying capacity. Okay? The insulation of the armature winding. But in case of DC motors, even more important than that is how much current your commutator can allow to flow. Okay? Is this clear? Because at your commutators, sparking is possible if a very high current flows. So this current I1 is decided by the commutation circuit, how much your commutation circuit can handle. So normally this current will be 2 to 2.5 times the rated current. Okay? If your rated current is 5 ampere, you are saying that only 10 ampere current can flow through the armature circuit at the time of starting, not 25 ampere. Am I clear now?
Yes, sir.
Okay? Sure. So I1 is decided by the commutation circuit. Okay? It should not be 2 to 2, not more than 2 to 2.5 times the rated current. How to decide the value of I2? And we are deciding this range. You are the engineer. This range is in your hands. Okay, you have to decide the range. So you have said that I1 can be 2 to 2.5 times the rated current, not more than that. How much should be I2 now? You are the engineer. Tell me, how much should be I2? Yes, anyone? Should I2 be equal to the load torque or greater than load torque or less than load torque? Or mu2 should be equal to the load torque, greater than load torque or less than the load torque? Let us say the load torque is equal to the rated torque of the motor. Okay, this line corresponds to the rated torque of the motor as well as the load torque. So mu2 should be greater than mu, equal to mu or less than mu.
So greater than.
Greater than, you can see it there. It is greater than. Why greater than? Why not equal? Why not less than?
So per unit value means here it is increasing.
No, no. Why mu2 is kept greater than mu? Why not equal to mu? Why not less than mu?
For stable operating point.
Right. There is no stable operating point here. The stable operating point will be along this line. There is no stable operating point here. Your motor is not stopping, is not running at a constant speed anywhere here. It will run at a constant speed along this line where the motor torque will be equal to the load torque. So why mu2 is kept greater than mu?
Sir, to make
Somebody else, Navneet.
Sir, for stability condition.
No, there is no stability here. Come on. There is no equilibrium and no stability along this line. Kalyani, why is mu2 greater than mu? Anyone else? Suman? Sumit and Suman.
yes, sir.
Why is mu2 greater than mu? Very simple answer. Very simple. So the simple answer is that
So drop is increasing.
no. Because you want the motor to accelerate. Correct? When will the motor accelerate? Right now the speed is 0. You want to increase the speed. The motor should accelerate. When will it accelerate? Only when
Load is increasing.
Torque is more.
load is constant. Yes, Sumit, you are saying something.
Torque is more.
Yes. When the motor torque is greater than the load torque. Simple concept. Correct? The motor will accelerate only
Yes,
when the motor torque is greater than the load torque. And that is why you are keeping mu2 greater than mu. Okay, where mu corresponds to the rated torque as well as the load torque. You want the motor torque to be greater than the load torque so that your motor accelerates. Okay? Clear?
Yes, sir.
Yes, sir.
Okay. Ideally, do you have any class after this? Immediately?
No, sir.
No?
No, sir.
Sir, we have exam at 4:30, sir.
4:30. Okay. I'll take class till 4 o'clock then. Okay. We'll finish this topic today, however much time it takes. Okay. So ideally, you want the motor torque to be as much greater than the load torque as possible so that you can get fast acceleration of the motor. Okay. But you have some limits. The upper limit is because of your commutator. The commutator is not allowing any more current than I1 to flow. Okay. So the commutator has decided this upper limit. Now the lower limit is in your hands. Okay. You can have it here, you can have it here, you can have it here. Okay. You can have it here at point A, you can have it here at point B, you can have it here at point C, You can have it here at point B. Is this clear? Am I clear?
Yes, sir.
This mu2 can be at point A, can be at point B, can be at point C, can be at point D. It cannot be here. Okay? And it can definitely not be less than here. Now the question is, what is the difference? A, B, C, or D? What difference does it make? What difference does it make? Why not have it here? You will have very fast acceleration. Why not have it here?
So the difference in the resistance, external resistance.
No, not difference in external resistance. You will need a lot of external resistances. Okay? Here, how many external resistances do you see? 3 sections. Okay? As you go on shifting this point towards the right, your external resistance sections will go on increasing. Okay? Is that clear, everyone?
Yes, sir.
As you go on towards the right, your external resistance go on increasing. In fact, infinite external resistances and infinite conductors, mu1 and mu2. Now this difference, as you go, number of external resistance sections goes on increasing. Okay. So as your mu2 shifts to the right, external resistance sections go on decreasing. As your mu2 shifts to the left, external resistance sections go on, sorry, as you shift mu2 to the left, the number of external resistance sections will go on decreasing. But you will get faster acceleration when mu2 is to the right. You will get slower acceleration when mu2 is to the left. So there has to be a compromise between how much faster acceleration you want and how many external resistances you can have. Okay. So what do you say? An agreeable compromise is to have mu2 about 10 to 20% greater than mu. Okay. How much is this? If this is 1, and this is 2 to 2.5, so this can be at 1.1 or 1.2. Okay, is this clear?
Sir, how we will calculate the specific value of mu2, sir?
That is what I'm saying. You assume the value, either 10% or 20%. Okay, you are not calculating it. This is a design problem. Yeah, there are 2 types of problems. One is analysis, another is design. Analysis, you are given the values of RRH1, RRH2, RRH3, and you find the values of mu1 and mu2. Okay, so that is an analysis problem. But we are not analyzing, we are designing. We do not have the values of RRH1, RRH2, RRH3. Okay. So in case of design, you assume, okay, this value is decided. There is no assumption here. This is decided by the commutator circuit. This value is to be assumed, and then you will find the values of RRH1, RRH2, and RRH3. Or if you want, you can have RRH4 also, you can have RRH5 also. But then you have to shift this to the right. Okay, is this clear? Am I clear?
Yes, sir.
Yes or no? Only Sumit is saying yes, sir. Okay. So the design problem, you assume the value of mu2 or I2, and then from that you'll find the number of external resistors and their values. Okay. So let us say I'm assuming that I2 is 20% greater than the rated current. Okay? That gives me an acceptable acceleration without having too many external resistances. Okay? So this mu1 I have drawn corresponding to the maximum permissible armature current. And this mu2 I have assumed to be slightly greater than the rated torque. Okay, is this clear? Yes.
Yes, sir. Yes, sir.
Now, I am having at the time of starting, the speed is zero. The speed is zero, the back EMF is zero. So to limit the starting current to I1, I am having all three resistances in the armature circuit. That means all these three contactors are open. All these three resistances, I will call them now R1, R2, and R3. Instead of RH1, RH2, and RH3, I am simply calling them R1, R2, and R3. So at the time of starting, I'm having all external resistances R1, R2, and R3 in the circuit. Okay. So how much should be the value of R1, R2, R3? How much should be the value of R1 plus R2 plus R3? Now this is a very simple question. How much should be the value of R1 plus R2 plus R3?
BE.
How much should be the value of R1 plus R2 plus R3?
Sir, applied voltage divided by maximum permissible current and
Correct.
minus the
Correct.
armature resistance.
Correct. R1 plus R2 plus R3 should be such that the external resistance is R1 plus R2 plus R3 plus the armature resistance should be able to limit the starting current to I1. Okay? Or B divided by R armature plus R1 plus R2 plus R3 should be equal to I1 in per unit. Okay, is this clear? Yes? Yes or no?
Yes, sir.
So I put that, okay, I know the value of I1, I know the value of V, I know the value of armature resistance. So I find the value of R1 plus R2 plus R3 and I keep that much resistance in the armature circuit so that when I am closing the line contactor L and the motor is starting, my starting current is limited to I1 in per unit. Okay. Now from this point, what happens? The motor speed starts increasing. Okay. So your motor, your operating point, this was the operating point initially, the operating point starts moving along the motor speed torque characteristic till it reaches point 2. Okay. Your motor speed increases to such an extent that your back EMF increases to such an extent that your armature current reduces to I2. Is this clear? Yes.
Sir, please repeat once, sir.
You have put external resistances in the armature circuit so that at the time of starting and the back EMF is 0, the motor current is I1. Okay. Now, current starts flowing in the motor and your motor speed goes on increasing. As the motor speed increases, the back EMF, what happens to it?
Sir, increases.
Increases. So your armature current
Decreases, sir.
decreases.
Decrease, sir.
Your motor torque also decreases. Okay? So your motor operating point now shifts along the speed torque characteristics. Speed is increasing, current is decreasing. Is this clear?
Yes, sir.
Speed is increasing, current is decreasing. Okay. Till it reaches this point, point 2. It It started from point 1 and reached point 2. Okay? If you do not remove the external resistances, what will happen? It will continue to moving along this point, and this will be your equilibrium point when the motor torque becomes equal to the load torque, stable operating point. Okay, clear?
Yes, sir.
Yes. But you have inserted the external resistance only for limiting the starting current. You do not want to. You do not want those resistances to be permanently present in the circuit. So what you are going to do, as soon as the current reaches I2, you close one contactor. Which contactor? 1A. You are closing the contactor 1A. So as soon as you close the contactor 1A, this resistance R1 is removed from the circuit. And as soon as R1 is removed from the circuit, instantly, if you neglect the armature inductance, instantly the armature current will increase. Okay? Yes or no? As soon as you
Yes, sir.
clear out one section of the resistance R1, instantly the armature resistance decreases, instantly the armature current increases. Does the motor speed also increase instantly? Can the motor speed increase instantly? No, because it has inertia. Current also has inertia, but you are neglecting the armature inductance. Okay? So instantly what happens? Your operating point shifts from 2 to 3. The motor speed is constant, but your armature current has increased from I2 to I1. Clear?
Yes, sir.
Yes. Now, again, it starts moving along this characteristic and reaches point 4, where again the armature current becomes equal to I2. Again, you close the contactor 2A, so that instantly the motor speed remains constant, but current increases back to I1. Now it moves from 0.5 to 0.6. Here you close the contactor 3A. Again, it shifts from 0.6 to 0.7. Now there is no external resistance in the armature circuit. So the motor is operating on its natural characteristic and it will move like this. And this is the equilibrium point where the motor torque becomes equal to the load torque. Your motor will continue to operate at point small e. Is this clear to everyone?
Yes, sir.
And the answer to the next question, all of you already know. How much is the value of R1?
1 amp.
How much is the value of I1? How much is the value of R1? Yes,
V by
V
I1.
by V by I1.
it is DE in per unit.
E.
How much is the value of R2? It is
D.
CD in per
CD.
unit. How much is the value of R3? It is BC in per unit. And this is the armature resistance in per unit. So this is how you find the values of R1, R2 and R3. Okay? Clear? Yes or no?
Yes, sir.
Okay. So that is the end of today's class, and till this point is your syllabus for the exam on Wednesday. Okay?
Okay, sir.
Hello, sir. Am I audible? Hello,
Yes,
sir.
yes, very good.
Sir, my mic is not working. I'm Shubhajit, sir. From the beginning, my mic is not.
I marked your attendance, don't worry.
Sir, mine also. Hello.
Hmm.
Sir, at the time of attendance, I was not online.
Abhishek, roll number
Yes,
2.
yes, sir.
Okay. Sure. So we'll have a class tomorrow, but that will not be in
Sir?
your answer.
Sir.
Yes.
Sir, can you please upload after today's video? There is some network issue in my end, and I cannot attend the class fully, sir.
I'll upload it. I'll upload it after some time, around 1 or 2 hours. Okay.
Okay, sir. Thank you, sir.
Okay. So we'll have a class tomorrow, but that what I will teach tomorrow will not be included in the exam day after tomorrow. Okay. Any questions?